Okay. Is it stuff you can verbalize?
The stuff on the pages we worked on, I need to go over.
Okay, hold on. I don't know where we left off. I've got 1 through 6 here. Let's try opening number 4.
Those two recent ones.
Sorry?
The two recent ones that my mom sent you are the ones.
That be 5 and 6? I think we covered 1, 2, and 3 the other day. Here, let me open 4 and see if this is something new that we haven't covered. Did we cover that?
Kind
of think we did.
Yeah, we did.
Well, then let's go to 5. Let me open 5. Do not believe we covered this. This is just factoring.
I don't think this is mine.
Do you have problems you can verbalize?
No, I don't think this is like my stuff at all.
That's why I'm saying, do you have problems you can verbalize? If this is not your stuff, then I need stuff. If you can verbalize it, I'll write it out.
I don't know. I don't have anything to work on. We have no problems on Google Classroom. We have no problems on Google Classroom. Yeah, I need to work on a cheat sheet. That's it. You already emailed them the two that I wanted to look at.
Well, we had problems, Jackson. I had 6 pages of them. We didn't cover all 6 pages the other day.
Yeah, it was only.
Pretty sure we did not cover this page. If this is your stuff, we need to cover it. You have problems.
No, this isn't the stuff my mom emailed you.
All right. Well, hold on. Let me see if I can find where she emailed me. Or what she emailed me. Desiree Hayes, this is it?
No.
We've done those?
Yeah, that is it.
Yeah, but we've done these.
Yeah, but I gotta go over like the subjects and stuff on them.
You want to go over these again?
Not those ones, the other page.
Okay. I don't have a second page. When she emailed me, hold on, maybe I do have a second page here. These were the ones that were all lateral in a zip file. I couldn't use them. Can you send me those again?
Yeah.
Take them one at a time and send them vertical. Actually, if you take them one at a time, it doesn't matter if they're vertical. I can rotate them. But they need to be one at a time, not in a zip file.
Okay.
Tell me when it's been sent so I'll know to look. It has to say file sent on your end, or your mom's end, whoever is sending it. In other words, if it says file sending, it hasn't been sent yet. All right, I just got a signal that I got something. There it is. Okay, this will work. Hold on. If she's got more stuff beyond this page, have her go ahead and send that now while we're working on this page.
I have nothing else to send.
Okay. Well, this works. Hold on 1 second. Let me get my files downloaded. All right. Is this the page you want to go over?
Yeah, just not so blown up.
Okay. Where do you want to start?
Up to you.
I'm sorry, what?
It's up to you. I already did this. I just have to go through it.
Well, you've done all of these?
Yeah.
Jackson, you need to tell me what you need to work on. I don't know. All of these have been answered, so...
I just have to study. No, it's all over the whole entire video. I do not need it.
These are definitely good questions to go over. This is for your final review. Just need to make sure you know how to do these. So, let's start with number 1. Tell me how to do number 1. What's the very first step you do?
You subtract 12.
Okay, what do you get after you do that?
You get negative 2x.
No, where are you getting the negative sign? There's no negative in front of the 2x.
No, it's 2x equals negative 12.
What's next?
And then you divide 2x into negative 12.
Hold on. Wait. Always remember your goal. When you're trying to solve an equation, you're trying to get to that. X equals something.
Yeah.
The way you do this is you get rid of everything that's with the X. Well, what is with the X right now?
2, but...
What's it doing? Is it multiplying? Is it adding? Is it subtracting? Is it dividing?
It's dividing.
No, it isn't. It's multiplying. It's 2x. So, the way you get rid of it is to always do the opposite.
Yeah, you divide 2x
By
12, negative 12, and that equals...
By 12, by 2.
Yes, by 2 and then...
Get rid of the 2. Since I can do both sides of the same thing, what is x equal to?
X is equal to negative 6.
Okay, good. Problem 1 down. Let's go to problem 2. Here, let me write it out again. 2x minus 5 equals 5x plus 7. What's the first step?
2x minus 5. Well, you subtract 5x.
Okay, tell me the next line.
And then it'd be negative 3x minus 5 equals 7.
Good.
And then you add 5,
Next line.
7, and then it's negative 3x equals 12.
Next line.
Equals negative 4 after you divide 3x into
Perfect.
12.
That's what you always do when you solve equations, is you get rid of everything associated with the x. That's all you do. It's that simple. Just get rid of everything else. All right. Number 3. Quite simple. You're just trying to find the slope.
So you do x. No, it's y2 minus y1, and then x2 minus x1. That's the formula.
What is that in this case?
12 over negative 6, which equals negative 2.
Good. Number 4.
Y equals negative 3x because
Well, read the question. Which equation has a slope of negative 3? Let's start there. Which two equations have a slope of negative 3?
A and B.
Not
No, I mean A and C. Sorry.
C. B and C. Okay. Which one of those has a y-intercept of plus 5?
C. What if you do y equals mx plus b?
That's it. We're done with number 4.
3 is m, and then b is 5.
Yeah, number 4 is really easy. Let's look at number 5. What's the first thing you have to do on number 5? It's always the first thing you have to do.
You gotta find the slope.
Okay, what's the slope?
Slope is 3.
Okay. What's the general equation of a straight line?
Y equals mx. Wait, no, that's slope. Sorry.
No, you got it right. That's the general equation of a straight line. Well, how much of that do we know? What do we know about it? Don't we know the slope?
We know m. Yeah.
Okay, so what's the rest of it?
Y equals 3.
That's all we know at the moment. However, we know that that equation goes through one of these points, both of them. We can use either point. Which one is the best one to use?
Probably
Whatever one has the smallest numbers.
4.
No, 3 and 5 are smaller than 4 and 8.
But 4 and 8 is easier to work with.
Okay, I don't care which one you use. So tell me the next thing to write.
Y equals 3x minus.
No. Each of these points is an xy coordinate, which means whichever point you use, plug it in for x and y. That's always the next step, is to pick a point. Notice that that point is an x coordinate and a y coordinate.
Yeah.
So, if we're going to use 4 and 8, tell me the next line. What's y?
Well,
This is the x coordinate, that's the y coordinate.
I don't really know how to do it this way.
Well, this is the only way to do it. Unless they've taught you point slope. Have they taught you point slope format?
I think so.
Well, I didn't want to confuse you by introducing that, particularly when you can do it this way. In other words, if I have an x and a y, I can plug them in, and then I'll be able to solve for b, right?
Yeah.
If I plug in numbers for y and x, the only unknown is b. So what's the y?
The y is 4, made of 4.
No, it isn't. That's the x. Remember, when you have a coordinate point, the first number is the x, the second number is the y.
Yeah, it's y equals 3x
Okay, so
minus
what's the y? What
negative
number?
4.
Up here. We're using that point. What's the y?
Oh, 8.
Okay. Equals 3 times what's the x?
The x is 4.
Now notice we only have one unknown. Solve that for b.
I'm sorry, but I don't know how she taught me this, but I don't.
Doesn't matter how she taught it to you. Do it the way I'm teaching it to you. I know you can solve that for b. Do it.
12 would be divided by 3.
No, this is 3 times 4 is 12. But if I have 8 equals 12 plus b, what is b?
Um,
Solve this equation. You got to be able to solve that equation. You can't even begin this test. You can't solve that equation. Understand that all algebra comes down to solving equations. You've got to be able to solve an equation with one unknown.
wait, 8 equals 4.
How do you solve this equation on the top left for b? What is with the b that you got to get rid of?
12.
What is 12 doing? Is it adding, subtracting, multiplying, or dividing?
Adding.
So you do the opposite. If it's adding, what do you got to do?
Subtract.
Okay. When I subtract 12 from both sides of the equation, what do I get for an answer?
Get
What's 8 minus 12?
negative 4.
Okay, that's what b is. Now that I know what b is, go back to over here. I knew that y was equal to 3x plus b, so therefore y must be 3x minus 4. There's your answer. That is the equation of a line. When you have the final equation of a line, it always has the y and the x in it. What you're solving for is the m and the b. Now, let me go over the way she might have taught it to you. Maybe it'll make it a little more understandable. We already figured out what the slope was, right? Slope was 3. Now, there is a point slope equation. Y minus y1 equals slope times x minus x1. Does this look familiar?
No, the way she taught me is actually on the problem. Since the slope was 3, it was y equals 3 x minus 8 plus 4, and the x minus 8 was in parentheses.
So I see the notes. She figured out slope, which is 3. She substituted it. And quite honestly, I can't figure out what else she did there. Doesn't make any sense to me. The way to do it is the way I showed you how to do it. Not this. If she hasn't taught you point slope format, then you don't want to use that. If you're not using point slope format, which is actually a little easier to use, then you have to use y equal mx plus b format.
Yeah.
Well, if you're going to use y equal mx plus b format, there's really only one way to do it. You figure out the slope, which is 3, and then you substitute whichever point you want. You could substitute that point, or you could substitute that point for the x and the y values. And that allows you to solve for b. Once you've solved for b, you have your answer. Now, you told me to use 4 and 8. I'm going to use 3 and 5. Okay, so y is 5. See that?
Yeah.
When x is 3, well, what do I get here? I get b equals minus 4. Same thing I got the first time. So that tells me what my equation is. Y equal 3x minus 4. Once I've solved for b, I know the equation because I know m and I know b. Remember, that's what you're trying to solve for. You're not trying to solve for y and x. You're trying to solve for m and b. Well, m you can solve for right off the bat. You did so right there. It's equal to 3. And then the only thing left to do is to solve for the b. And you can use either point to do so.
Yeah.
All right. Number 6. We did number 6 last night.
Yeah.
You want to do number 7? I can go
Sure.
over number 6 again. Number 6 is a little unique in the fact that it talks about x and y intercepts. And the most important thing you can remember about number 6 is that when you're talking about x-intercepts, y is what?
Y is, wait.
When you are talking about x-intercepts, what is the value of y?
0.
When you are talking about y-intercepts, what is the value of x?
0.
Okay, that's how you're going to solve this problem. You got minus x minus, forget her notes. If I want to know the x-intercept, what am I going to let y equal to?
0.
When I let y equal to 0, what is the next line?
X.
It's minus x. Correct? If I'm letting y equal 0, well, then this term goes away.
Yeah.
With me?
Yeah.
So if minus x equals 42, what's x equal to?
X is equal to 41.
No, you're dividing both sides by -1. That's how you get rid of that negative sign in front of the x. You're not subtracting, you're not adding. That negative sign is a multiplier. So you have to divide to get rid of it. So x equals minus 42. With me?
Yeah.
Now, to solve for the y-intercepts, what am I going to do?
You're gonna,
What are you going to let x equal? That's the thing.
0.
So if I let x equal 0, that disappears. And I get minus 7y equals 42. Now solve that. What's y equal to?
0.
What's with the y?
Oh, 7. Negative 7.
Negative 7, not 7, negative 7. How do I get rid of, what is the negative 7 doing?
It's subtracting. No, multiplying, I mean, sorry.
Subtracting.
It's multiplying.
Okay, so what do I have to do to get rid of it?
Divide.
Okay, so I'm going to divide both sides by negative 7. That gets rid of the negative 7 on the left side. Now I got y equals what? What's 42 divided by negative 7?
42 divided by negative 7.
42 divided by negative 7. You don't have a calculator, get one.
Oh, it's 6. Negative 6.
Negative 6. So that's your y-intercept. Why? Because I let x equal 0. The x-intercept is negative 42. How did I get that? By letting y equal 0. So that's why that's the answer. Because the x-intercept has a y of 0, and the y-intercept has an x of 0.
Yeah.
That's how you do x and y intercepts. It's actually quite a bit easier than solving the equation. It's really, really simple. When you're finding the x-intercept, you set y equal to 0 and solve. When you're finding the y-intercept, you set x equal to 0 and solve. All right, number 7. What's the standard format for a straight line?
Y equals mx plus b.
What do we know about this line looking at it?
It's not straight.
Well, it is straight.
It's not straight.
Yes, it is. It's a straight line. I'm not talking about the red line. I'm talking about the black line that they put on there.
Yeah.
Okay. Where do we start? When we're translating that graph into an equation, what point can we see for sure is on there? B? Is it M?
M.
What's B?
B is 4.
Okay, well, let's put that in there. We know that. Y equal mx plus 4. What's M?
M is 2.
Nope. Rise over run.
Oh. 2. No, negative 4 over 2.
Nope. There's your 1 point. There's another point. Put it through your slope equation. What do you get?
Where? I don't see it.
All right, hold on. Slope's equal to what?
Y equals mx plus b.
No, slope is equal to what? Remember, the first thing you have to figure out on all these problems is what is the slope? Rise over run. What's the rise?
8, negative 8.
Oh, okay, that's fine. Negative 8 over what?
2,
Okay, what's that?
negative 4.
There's your slope. So if y equal mx plus b, we know what m is and we know what b is. What's the equation of that line?
The equation of that line.
Just figured out slope. Let's put that in.
Oh, y equals -4 plus 4.
Negative 4x.
X plus 4, yeah.
There's the equation of that line. Hold on 1 second. Hey, Dave. Unfortunately, I'm in a tutoring session and I got another one at 8. So I'm really tied up tonight. But otherwise, I wouldn't mind it at all. I would love to do it, except for I'm tutoring. But I will see you Thursday. Bye-bye. Okay, go ahead, Jackson. So, you see what we did? When they give you a graph, they're giving you B, right?
Yeah.
Okay, once they give you B, the only thing you need is M. And M is just rise over run. You can do it using these 2 points, or you can do it just looking at it. It goes up 4 and over 1. So you can figure out what the slope is, and you can see that it is a negative slope, right?
Yeah.
In other words, you know that's not a positive slope. So if you get 4 for your slope, you got it wrong. Always make sure your slope has the same sign on it that you can see. When you look at a line, you know whether it's positive or negative slope. Make sure the answer you get matches it. All right, the other one is the last one on this page. Again, where do we want to start? What are they telling you by the graph?
That y.
What's the very first thing they're telling you? What's the easiest thing to get? Is it M or B?
Oh,
No, B. What is B?
Oh.
B is the Y-intercept. You're staring at it.
Oh, 1?
Is it 1?
Yeah.
This is the Y-intercept right there. The Y-intercept means where it crosses the Y-axis. That's what it means.
Yeah.
Where does this thing cross the Y-axis?
-1.
Okay, so B is -1. Now tell me what slope is. Once we have slope, we'll have the equation of the line. Take your 2 points, figure out slope.
1/2.
It's 1/2, exactly. So what's the equation of the line?
Y equals 1/2 x minus 1.
Perfect. That's the way you do it. You figure out B, you figure out M. That's all you need for the equation of the line.
Yeah.
Now, these last 2 problems you could not verbalize. You have to send me a picture of. Because it's a picture of a graph. You can't verbalize that. That's the last problem on this page. I do not have another page. So, do you have other problems you can verbalize, or do you need to send me another page? Let me check and see if your mom has sent me another one. It looks like she has.
Oh, okay. Goodbye.
Yeah, let me take a look at these. Yeah, she has, I believe. At least she has sent me one. Which will be enough to get us through this session. All right. We have not done this. Yeah, we've done this. We did this one yesterday. We did this page yesterday.
Yeah, I just have to re-go over it.
Want to go over it?
Sure.
All right, where do you want to start? We got 15 minutes.
Let's start the top two because it's still.
Okay. The top problem. Pretty easy. Here's what we have. Let me expand it just a little bit. Whenever they give you values for all of the variables, in other words, they tell you what A is, they tell you what B is, they tell you what C is, what are you going to do?
Add them together.
You're going to plug them in. It's not always adding. B is not being added to C. B is multiplying C. So the answer is you plug them in. So tell me what to write. Instead of A minus BC, just plug in what A is, what B is, and what C is.
2 minus 18. Negative 18.
I want you to plug it in. I don't want you to do that math in your head because you mess up the sign sometimes. If you plug it in, and now I'm looking at it, I can't make a mistake there. What's the next line?
Next line is 2 minus negative 18.
It's 2 minus negative 18. Simplify that.
And that is 20.
Perfect. That's all you do. Those problems are a piece of cake. Just don't do more than one step at a time. That's the secret on those kind of problems. Is if they give you all three variables, just plug it in, put parentheses around it, and then simplify it. It's always the solution. Okay?
Yeah.
Number 10. I have a fraction over equals another fraction. How do I do fractions equal fractions? What's the word? Cross.
Oh, cross multiply.
Okay, what's the next line? Cross multiply both ways. Do it that way equals that way. That's what cross multiplying means.
So 1, 3.
Tell me what that is. Don't tell me 1, 3. 1, 3 is 13.
Oh, it's 10 over 3.
What's 1 times 3?
3.
That's all it is. What's the other half of it?
10.
What is 2 times C plus 5? Here's what we're doing. That's what cross multiplication is. It's the denominator times the numerator on the other side equals the denominator times the numerator. Understand?
Yeah.
Now what? I got 3 equals 2 times the quantity C plus 5. Trying to solve for C. Always get rid of parentheses.
Yeah.
Tell me the next line.
What is that supposed to be?
3 equals what?
3 equals 2C plus 10.
What's the next thing we got to do?
You gotta subtract 10.
So what's the next line?
From 3. So it's 7.
Nope. What's 3 minus 10?
Negative. Yeah, negative 7.
These negative signs are not trivial. You cannot drop a negative sign. If you drop a negative sign, you're missing the problem.
Yeah.
Understand?
Yeah.
It's the most common error in algebra, is dropping negative signs. Everybody loves to do it because everybody hates negative signs. So they want to get rid of them as fast as they possibly can. And unfortunately, most students get rid of them way too soon. You cannot drop a negative sign ever. So what's negative 7 equal to?
Negative 7 is equal to 2c.
Now what's C equal to?
Negative 7 over 2.
There you go. Once you've isolated C, you have your answer. And that's answer B. In other words, negative 7/2 is the same as negative 3/2. You see that?
Yeah.
Right here, negative 7/2 is equal to negative 3.5. Okay, number 11. There are about 4 ways to do number 11, but the way they want you to do it, based on this, is as a ratio problem. In other words, the left side is 80, a distance, 80 miles, right?
I'll be right back again. Ally! It's going to run. Alright. What?
Okay, we're doing number 11.
Yeah.
And what they've given us is a distance and a time on the left side of the sentence. So the distance is 80 miles. The time is 1.3 hours. This is a ratio problem. What goes on the right side? The only thing they give you on the right side is a time. Where does that go? Does it go on the numerator or the denominator?
Numerator.
Where is it in the left side of the equation? Where's the time?
Oh. Denominator.
Okay, that's where it needs to be on the right side also. 4 hours. What goes in the numerator? So far, we're looking at nothing but numbers. What are they asking you for? How many miles? What is that? That's a distance, is it not?
It is.
Okay, then we're going to put that. That's our variable. In other words, that's the unknown.
Yeah.
Now, solve that. For D. In other words, what they want is D. How do I get, what is on the same side as D?
4.
What is it? Is it dividing, multiplying, adding, or subtracting?
Subtracting? No, dividing, sorry.
Okay, so how do I get rid of it?
Multiply.
Okay, so I'm going to multiply both sides by 4, correct?
Yeah.
It gives me this on the left. 80 times 4 divided by 1.3. Well, that equals D. They're asking about D.
Yeah.
So, because that's what they get here, 320 divided by 1.3, but you kind of need a calculator to narrow that down to an answer. So divide 320 by 1.3. What do you get?
Ooh.
Do you have a calculator?
Not on me.
You need a calculator, Jackson. We can't do these sessions unless you have a calculator in front of you. Every time. Because we run into problems like this. They don't have 320 divided by 1.3 as an answer. So you got to convert that to a number as close as you can. Now it does say approximately, so we're not going to see the exact answer. But what is, you need 320 divided by 1.3.
Well, it's 246.15, and if you
So
want
what's
to, you
the
can
answer?
round down.
If that's what you get, and you're presented with those four choices, you got
round
20, you got that, you got that, and you got that. Which is our answer?
245.
Okay. But you'll notice that we had to answer that. What is 320 divided by 1.3? You can't do that in your head or manually. You need a calculator to do that. All right. We have number 12. 12 is, I will admit, a little confusing. Let me see if I can explain 12 a little bit better for you. These are always a bit confusing to people. They get them backwards. The way to not get it backwards is let's draw a graph. Okay? That's the M axis, that's the N axis. Always put them like that. The first column is the horizontal axis. You with me?
Yeah.
Let's plot those points. Well, there is 2, 4. You see where I'm getting that from? 2, 4?
Yeah.
Okay, there is 3, 6. There is 4, 6. And there is 5, 4. It's a little scribbly, but you should be able to see that if I connect those dots, I get that. Right?
Yeah.
Is that a function?
Yes.
It is, because it passes the vertical line test. No
Yeah.
matter where I put a vertical line, it only goes through one value for y. Every single vertical line I have on there has a different value for y. Or, excuse me, for every value of m, it has precisely one value for y. That makes it a function.
Yeah.
Okay, now let's look at the second one. And this is confusing, I will admit it. But if you just draw a graph and plot some points, you'll see what happens. Well, where's 2, 6? Right there, right?
Yeah.
Where is 3, 4? Right there, right?
Yeah.
Where is 3, 3? Right below it, directly below it. And finally, where is 4, 1? About there. Now, if I connect those dots, does that pass the vertical line test?
Yes.
No, it doesn't.
No, it
I
does
drop
not.
a vertical line right through there for
Because
a specific value of m, namely 3. I get 2 different values for n. I get 4 and 3. That
because one
fails the
input.
vertical line test. That is not a function.
Yeah, because and isn't it also because one input has two outputs?
Exactly. And over here it says, the first one is a function because every input has only one output. The second one you cannot say that about. The second one, when your input is 3, you have 2 different outputs. You have a 4 and a 3. That makes table B not a function. And you can see it graphically. By our graph, you can see that that does not pass the vertical line test. Here, let me give you a test on that. I'm going to draw some functions. You tell me which ones are functions, which ones aren't. Is that a function?
Yes.
Is that a function?
No.
No, because if I draw a vertical line, it goes through two values of the y-axis, right?
Yeah.
In other words, if this were the point 1 on the x-axis, I would have 2 points. That violates the rules of a function. How about this one? Let me do one more. This one is the hardest one to see. Is that a function?
No.
No, because if I drop a vertical line right there, I get about 18 values of y for the same value of x. That does not pass the vertical line test.
No, it doesn't.
So that graph that I just drew is not a function. In the same way that if I would have drawn the graph like this, that's not a function either. I can put a vertical line right through there.
Yeah.
All right. Jackson, it's 7:30. I'm going to have to go. Your test is tomorrow, right?
Yeah.
Good luck. You've made some progress. I hope our last 2 sessions have helped.
Yeah.
And if I don't talk to you again, you have a Merry Christmas.
You too.
All right, Jackson. Good night.
You're right.
Bye-bye.